What's up, beautiful physics people? This week we're talking about something brand new. We're talking about projectile motion. What is projectile motion? Well, last week we learned about rotational motion, circular motion, right? When David spun his sling and threw the rock and killed Goliath by hitting him in the head, he was using circular motion. Now let's talk about the path that rock took to get to Goliath's head and kill him. That is projectile motion. So what is projectile motion? Projectile motion. Well, it's motion that involves a projectile. What is a projectile? Well, the rock that David threw at Goliath was a projectile, right? If your grandmother throws her chancla at you, that's a projectile. If I throw this at another teacher, that's a projectile. If we launch a rocket into the air, that's a projectile. A projectile is any one of these things taking any one of these paths, right, in two-dimensional space or three-dimensional space, and we call them projectiles, right? Something that's launched or thrown like that. That's a projectile. So we call this projectile motion, right? So how does it work? Well, when I have a projectile, let's say I throw a rock off of a cliff, right? Well, on Earth, it's going to take a particular path, right? So that path we call a trajectory. Trajectory. This path is called a trajectory, right? It's the path that a projectile takes. And the trajectory is super important because if we want to know how high the projectile goes or how far it goes, we're talking about its trajectory, right? So we have two things. We have a projectile, right, that moves in a trajectory. So our rock here, if I'm throwing this rock, moves in a trajectory before it hits the ground, right? So a couple things that I have to understand here, right? There are two things going on. This rock is moving up and down, and it's also moving left and right. It's moving up and down, and it's moving left and right. Do you see that? So we have to talk about these completely separately, completely independently. The left and right we'll call X, and the up and down, of course, we'll call Y because, you know, math. But this right here and this right here are super different, right? And it's confusing because you want to think that they're the same, but they exist independently from another. And that is what this lesson is all about, right? So let's talk about that. Let's talk about this real quick. If I were to throw that rock, and here I am, and I throw that rock, right? Right here. All right. This projectile takes a trajectory and hits the ground right here. Well, let's start talking about all the kinematic parts of this, right? Let's talk about it in this direction, right? So the ball, if I start by throwing it, it's got an initial velocity, right? It's initial velocity. Let's say I throw it at 10 meters per second, right? So it's going to fly through the air, right? And it's going to have some distance. It's going to go some distance. I don't know, right? Because clearly it's going to go some distance. This distance right here, this distance d, right? What about my final velocity? Do I know my final velocity? I actually do. Think about this. If I throw it at 10 meters a second, is it ever going to get faster? No, it's never going to get faster. Now here's the question. Is it ever going to get slower? You might say that, yeah, it's going to get slower. It actually doesn't get slower. It doesn't, because you're thinking about the other direction when it speeds up and slows down. It will never get faster in this direction. Remember, I'm not talking about overall. I'm talking about in this direction. Is it going to speed up or slow down left to right? No. So the final velocity is going to be the same, right? How about this? Is there an acceleration? Does it speed up or slow down in this direction? No, it doesn't. It does not. There is zero acceleration. Now, you might be confused because, you know, let's say this is 10 meters, right? It's gone 10 meters. You might be confused because you're like, wait, what about, like, gravity? It's like falling towards the earth and it's getting faster. That is true. but not in the X direction. Not here. Not in the X direction. That is happening in the Y direction, up and down, right? So in the X direction, we have a very, very basic scenario. 10 meters a second, and it's going to stay 10 meters a second, and it's going to go 10 meters. What you're thinking of and what everyone wants to think about is what happens up and down. Now let's talk about that. Up and down is a different story. If I launch the rock that way, it's going that way at 10 meters a second. In my hand, right before it leaves the ground, is it going down at all? What's the initial velocity going down? It's 0, right? The initial velocity in this direction, right? And I'm going to write this in blue, so you can think about this as blue right here. The initial velocity is 0. It's not 10. It's going 10 that way, 0 that way, right? Now, what is the final velocity here once it hits the ground? You should know that it's going to start from 0, and then it's going to get faster. It's going to get faster, right? Because it's going to accelerate at 9.8 meters per second towards the ground. Meters per second, every single second towards the ground, right? And we also have a distance, this distance of the cliff. So this right here is pretty complicated, right? We have stuff going on up and down and stuff going on left and right, right? But I don't want you to get too frazzled with it. All you need to know is that, 1, left and right and up and down are completely independent from each other. How do you know that, and how am I going to prove it to you? Well, what I'm going to do is I'm going to take a Nerf gun and I'm going to shoot a bullet and drop a bullet at the same time, right? I'm going to shoot a bullet and I'm going to drop a bullet at the same time. So here's my Nerf gun, right? And I'm going to shoot a bullet and it's going to fly and it's going to go hit the ground, right? And at the same time, I'm going to take the same bullet in my hand, and at the same time I shoot it, I'm going to drop it. And which one is going to hit the ground first, right? Which one is going to hit the ground first? Well, it will surprise you to know that they're going to hit the ground at the same time, right? Because up and down, gravity is acting on both of them at the same rate. Left and right doesn't matter, right? This one is just going to go further than this one, but they're going to hit the ground at the very same time. Because the X direction and the Y direction are completely independent of one another, right? In the Y direction, we have acceleration due to gravity. In the X direction, we have no acceleration, right? If I throw this, it's going to keep going that same speed until it hits the ground. If I drop this, it's going to increase its speed in the down direction, but it's not going to increase the speed that way. So these X and Y directions are the key to this lesson, right? That's the key to this lesson. So let's talk about this more in the quick check when we answer all of these problems, right? We're going to answer all of these problems together. Watch my videos right inside the quick check, and I'll get back at you.